Imagine a foggy intersection in San Francisco at 2 in the morning. A white SUV pulls up to the curb. The doors unlock, but there's nobody inside. The wheels turn smoothly on their own, guided entirely by silicone and code. To understand why a machine is driving this car, you have to look at how humans drive. We get tired. We text while driving. We get distracted. Because of those human limitations, distraction and fatigue cause roughly 94% of all traffic accidents globally. This chart shows the rate of serious injury crashes per million miles driven, comparing human drivers to modern autonomous fleets like Waymo. The machines show a drop of 85 to 91% in the exact same cities and conditions. Yet, despite that statistical safety, these systems are surprisingly clumsy. They can navigate a complex highway merge, but they frequently freeze up when they encounter a single traffic cone or a double-parked delivery truck. In April 2026, over 100 Baidu robo-taxis came to a dead halt in the middle of a busy ring road in Wuhan, China. A system malfunction caused the entire fleet to stop, trapping passengers in moving traffic for nearly 2 hours. These systems struggle because they are logical machines operating in a messy social environment. They understand the physical width of a lane, but they struggle to interpret the unwritten rules and body language of human drivers and pedestrians. For an artificial intelligence, mapping the geometry of a street is the easy part. The hardest obstacle to navigate is the unpredictable nature of the human mind. To solve those unpredictable edge cases, companies must collect data at a massive scale. Tech giants are fighting for every city street to train their software and refine their models. The industry is split on the hardware. Waymo uses LiDAR, expensive laser sensors that build high-definition 3D maps of the environment. Tesla relies on a vision approach, using cameras and neural networks to interpret the world like a human eye. The billions poured into these sensors target the underlying economics of the ride-hailing industry. This chart shows the cost breakdown of a traditional ride-hailing fare. Currently, roughly 70% goes strictly to the human driver. Removing the driver allows tech platforms to capture that entire margin, shifting transportation into a capital-light software utility. The goal is a total restructuring of urban transit. These companies are moving to replace labor-intensive services with a centralized, software-heavy monopoly. This transition challenges the current model of car ownership. Right now, a personal vehicle is a depreciating asset sitting idle 95% of the time, while still requiring insurance, maintenance, and parking. As autonomous fleets scale, the per-mile cost of summoning a robotaxi falls below the financial burden of owning a personal sedan. We are seeing the end of private ownership. Consumers are moving away from buying mobility as a physical product and starting to stream it as an on-demand utility. Once mobility is a networked utility, the physical city must respond. The streets fill with driverless vehicles that communicate and move in constant coordination, and this leads to an environmental inversion. The most effective way to solve AI clumsiness is to remove the unpredictable human variable from the environment entirely. When human drivers are removed, the infrastructure built to support them becomes unnecessary. The first major casualty is the parking garage. Because robotaxis circulate constantly to find new passengers, they rarely need to park. Eliminating mass parking frees up millions of square feet of prime real estate for housing and public parks. The second casualty of a predictable road network is the concept of stopping at intersections. Traffic lights exist to manage human reaction times and prevent collisions. In a networked environment, these manual controls become obsolete. This schematic shows centralized air traffic control for streets. Networked cars communicate trajectories instantly, interlocking their travel paths at high speeds without braking. This frictionless choreography is a mathematical certainty, requiring the total removal of humans from the wheel. The robotaxi is the mechanism that removes humans from the driver's seat. Once the human variable is gone, the city transitions into a centralized network where every movement is calculated, coordinated, and controlled.